1986, birth year of PC-based automation, where the world moved away from classical PLCs to PC-based controllers. Since then, Beckhoff has driven the convergence of IT and automation technologies further, and we will later discuss important milestones during this presentation. So how did the world look like in 1986? So everything was proprietary. We had proprietary hardware, we had no open operating system, and also no standardized operating system. There were no really standardized field buses out there, and everything, like I said, was proprietary and a closed system. So you can imagine that back in the days, I was still very young, so I was like 5 years old in 1986. So I really didn't know what was going on back then because I had other interests, right? I had a brief chat with my father a couple of weeks ago, and my father has worked for a woodworking company back in the 80s, before he actually started to work for Beckhoff. And so I asked my father, hey, what was the situation like before PC-based control? And actually, what made you choose Beckhoff for machine control? Because actually, the company that my father worked for was the first Beckhoff customer in the woodworking machine area. And my father said, well, just imagine the following situation. And he showed me a picture that he retrieved from his picture repository. And as you can see, it's very confusing. So there was a typical cabinet back in the 80s for automation technologies, a typical PLC, actually. And my father explained to me that with every machine, there was a cabinet especially for the PLC, which was like 2 meters high and 80 centimeters wide. And the total cabinet construction at a typical woodworking machine was like even bigger than that, like 6 meters or 7 meters wide. So, and he explained to me that every cabinet for the PLC had up to 3 module racks. And every module rack had about 8 32-bit I/O channels, and you see that here. So this is a typical module, and there were 3 of them existing in this cabinet construction. So that basically means that there were 256 channels per module and about 800 channels per cabinet. So a huge wiring construction, as you can clearly see here in this picture. And everything was in one central location, which means that all the wires had to go to the machine back and forth so that you could, or that this PLC could automate the machine. And in addition, there was also an operator terminal in a separate location, which was allowed, or which allowed to enter the program, manage the recipes, and also do access and line control. So this terminal was also, of course, wired to the PLC. So there were additional wires going back and forth between the operator terminal and the PLC because the operator terminal had to automate all the I/Os and had to access all of the I/Os, right? So in total, you could say that everything was very confusing. So everything was huge, everything was expensive, and everything was very hard to maintain. And wiring was also centralized, so there was no decentral I/O. And one day, a friendly gentleman named Hans Beckhoff called my father, and Hans Beckhoff said, hey, Mr. Goldstein, I have something new that Beckhoff has to offer. Beckhoff now has PC-based control with decentralized I/O via a new technology that is called Lightbus. And that was very interesting for my father because suddenly there was standardized hardware for the PLC, which was a regular PC that you could buy on the market. And there was a known and standardized operating system back in the days based on Microsoft MS-DOS. And there was also decentralized I/O, which means that the module racks could now be distributed, let's say, around the machine. So which means much simpler wiring and a much more organized cabinet construction in the end. And the standardized PC only required a Lightbus interface card. In addition, there was also programming which was very similar to the Siemens-like programming back in the days, which was based on instruction lists. So my father actually didn't have to learn any new programming language to engineer his automation project. And as a small fun fact, my father, after this call with Hans Beckhoff, my father called his automation supplier, and he asked his automation supplier, hey, did you know that Beckhoff now has a PC-based automation controller to offer with instruction list-like programming? And the automation supplier answered, no, this cannot be true. And if it is true, there is surely no future in PC-based control. And as you may know, this turned out to be wrong. So this is the first Beckhoff industrial PC that we launched on the market in 1986. It's the Beckhoff C4000, and it already has, I think, a very modern and sleek design, at least for the 80s. So let's jump into the year 1996, in which Beckhoff launched our first version of our TwinCAT automation software. So due to the revolution in 1986, we already had standardized PC hardware, we had a common and known operating system, we had a field bus, which was the light bus, right? And we also had more or less standardized programming, at least programming which was known for the automation expert, so instruction list. So, and thanks to TwinCAT, thanks to the developments inside of our TwinCAT automation software, everything could now happen within one software and one CPU. So PLC control, motion, HMI, everything happened suddenly in one software and one CPU, which was, of course, brought a lot of advantages. So minimized hardware costs, no hardware interfaces, so which was resulting in faster cycle times. Also a very reduced and minimal interface complexity, and of course improved diagnostics. So PC Control since then offers an open control system, so where abstraction is the principle and where more and more functionalities are developed in software instead of hardware. So let's jump into the year 2010. In 2010, Beckhoff launched the newest version or the latest version of the TwinKit automation software, TwinKit III. And TwinKit III brings more and more functionalities for the PC-based automation world. So now we have standardized programming based on IEC 61131 languages like structured text, instruction lists, so several programming languages that the PLC developer could choose from when automating his project. And with TwinKit III, it is now also possible to make use of multi-core CPU architectures, which means that you can take different PLC programs and deploy them to different CPU cores. And this, of course, brings a lot of advantages for the customer, because he can then scale his automation project according to the size and the complexity of his machine. As you can see here, TwinKit III itself is based on different modules. So we have a module for PLC, a module for C++ programming, safety configuration, HMI. And one of the main advantages in TwinKit III is also that you have connectivity to third-party applications, either on the field bus level, like EtherCAT, or also on higher communication levels, where you could take OPC UA, for example. So let's jump a few years into the future, into 2015, in which we launched a new product family, which is called TwinKit IoT, and which brings you connectivity from the PLC application into the cloud. So let's have a look at this classical connectivity pyramid, where you have real-time connectivity going on the factory floor, where you have very fast communication, very low latency times, and where hard real-time is a requirement. And then you have more or less different real-time requirements here on the PLC level, and of course no real-time requirements when you configure your devices to send data up to the cloud. As you can imagine, when you're doing local processing on the PLC level or on the factory floor, you have very, very high data rates for the data that's going back and forth between the PLC and the IOs. So the applications that are typically being used here are the classical machine control, vibration analysis, or power monitoring, or even vision, which all require very high data rates for the data that's being sent back and forth. So typically, before you send all this data up to the cloud, what you do is you typically place an edge device as a dedicated device in front of the PLC devices, and this edge device is then responsible to compress the data, to aggregate the data, maybe to do some further analysis on the data in order to before sending all the data up to the cloud. And when you do the connectivity to the cloud using standardized connectivity protocols like MQTT, OPC-UA, AMQP, or HTTPS, which you can also encrypt for data security, you can then take all the aggregated data and work on this data. And this totally makes sense for the customer, because in distributed communication scenarios where you have a lot of distributed applications, like a lot of different machine controllers that are sending the data up to the cloud, you want to aggregate the data, and you also want to correlate the data across different machine applications. So Beckhoff offers, like I said, a product family that enables our customers to do IoT connectivity with the cloud. And of course, every customer will believe us if we say, okay, take our newest version of the TwinCat III automation software and connect your automation controller directly to the cloud. And within the cloud, we offer connectivity with all the major cloud service providers like Microsoft Azure, Amazon Web Services, IBM, Google. So the customer decides himself which cloud provider to use for his machine application. But of course, we can not only connect our newest version of TwinCAT with the cloud, but we can also connect older devices, older TwinCAT devices in a retrofit or a brownfield scenario with the cloud using an edge device where we install our TwinKit IoT software on and connect this existing device to the cloud. And this, of course, also works for third-party devices, because our software tools use OPC-UA connectivity for underlying devices, and which basically means we can connect to any third-party device that has an OPC-UA server integrated and connect this device to the cloud. And one of the software applications that we offer here is the so-called TwinKit IoT data agent. And you see that here, this is the configuration tool for this IoT data agent where you design your data flow. So you configure in this data agent application which underlying devices the data agent should connect to. In this example here, 2 TwinCAT PLC devices and 1 third-party OPC-UA device. And then you design the data flow that should go back and forth between those devices and the corresponding cloud service. And of course, the different connectivity parameters that are being used for the cloud service can also be configured inside of this data agent configurator. So this basically means that we make this whole IoT connectivity scenario less complex for the customer, because the customer doesn't have to worry about bits and bytes in his data connectivity. Instead, he just uses the software application to easily configure the data flow between the machine controller or an edge device and the cloud service. So we are now in the year 2020, and in 2020, Beckhoff has announced his first cloud service, which is called TwinCat Cloud Engineering. And in TwinCat Cloud Engineering, the idea behind is that customers can go to the Beckhoff website, log into their user account, and then configure and rent a TwinCAT instance as a virtual machine, which is pre-configured and pre-provisioned in the Beckhoff cloud, and then also use this TwinCAT instance to engineer the automation project. And of course, it is not only possible to start TwinCAT here and work with TwinCAT in this TwinCat Cloud Engineering instance, but you can also connect this particular instance with your on-site machine application, because there are several connectivity protocols available that let you connect your cloud instance with a machine controller in the field. And this is an example how it looks like. So like I said earlier, you have a dashboard where you log in with your user credentials, and then you have an overview of all the rented TwinCat Cloud Engineering instances. You can interact with the instance, you can start it, stop it, and you can also connect to it. And what does that mean? So basically, when you connect to an instance, you simply use your web browser to do so. So the remote desktop connection that we use to connect to the TwinCAT application is being tunneled through the web browser. So you don't require any additional software applications in order to work with the TwinCAT installation.